We have a couple more problems to look at in section 2.4 and 2.5. First, I'd like to talk about parallel and perpendicular lines. Parallel lines have the same slope, and perpendicular lines have slopes that are negative reciprocals of each other. So, for example, if we know that the slope of a line is 3/5, then the slope of a parallel line is also 3/5, and the slope of a perpendicular line is going to be -5/3. So the reciprocal means flip the numerator and the denominator, and then the negative means we're going to change the sign. The positive slope becomes negative, or if the original slope had been negative, then the new slope would be positive. Okay, here in example 7, write the equation of the line that passes through the point 3, -2 and is perpendicular to the line 4x minus 2y equals 5. This should remind you of a problem that we worked a couple videos ago. And so in particular, you might be thinking of point slope form. Right, y minus y1 equals m times x minus x1. We have a point 3, -2, so that will take care of the x1, y1, and then all we need is the slope. And so if we know that the slope of our new line, if we know that our new line is perpendicular to this given line, then we can just find the slope of the given line and then take the negative reciprocal. So let's do that. So step 1, let's take 4x minus 2y equals 5, and let's solve for y. Minus 2y equals -4x plus 5, and then when you divide by -2, you're going to get y is equal to positive 2x minus 5/2. So the slope of this line is 2. So the new slope, the slope that we want, is going to be -1/2. Okay, and so we're going to take that -1/2 and that point at 3, -2 and plug into point slope form. We can call that step 2. And we'll get y minus y1, -2, is equal to the slope, -1/2, times x minus 3. And then we can just solve for y. We've done this a few times already. Let's see, that's plus 3/2. And then when you subtract 2 from both sides, you get -1/2 x minus 1/2. And that's your answer. Okay, the last problem I want to look at is an application problem. It says the pressure P on a diver's body is a linear function of the diver's depth, x. At the water's surface, the pressure is 1 atmosphere, and at a depth of 100 feet, the pressure is about 3.92 atmospheres. So first of all, let's find a linear function that relates P to x. So maybe the easiest way to do this is to make a table. We can write x, which is the depth, and then we can write the pressure, which we'd like to call P, although maybe for the moment, it'll be easier if we just call it y. Since we're used to ordered pairs x comma y, let's just do that for now. And then we'll change over to p maybe at the end of the problem. So we know at the water's surface, the pressure is 1 atmosphere. Well, what's the depth when you're at the surface? The depth is 0. So we have an ordered pair 0, 1. We could even write it as an ordered pair if that would be nice. That would make it look like some of the other problems we've been doing in this section. Okay, and then we also know that at a depth of 100 feet, the pressure is 3.92. So 100, 3.92. So all we're really asked here in this problem is to find the formula for the line that passes through these 2 points. So if you like writing them as ordered pairs, great. If you like writing it out in a table, that's fine too. You could call this x1, y1, and then x2, y2. That might help. And then, of course, what we've done already with a problem like this is step 1, find the slope. So find the slope. And so y2 minus y1 over x2 minus x1 and we'll get 0.0292. And then in the second step, we're just going to plug into point slope form. And we'll have y minus y1 is equal to m times x minus 0. That's a nice thing. That's going to simplify a little bit, isn't it? So we'll just have on the right side, we have 0.0292 times x. And then when we add 1 to both sides, then there's our answer. Notice we didn't actually need the point slope form. We actually could have gone straight into y equals mx plus b because we were given the y-intercept, right? The y-intercept is the y value when x is 0, and so that was already known to be 1. And so we knew the slope from step 1, and we were given the y-intercept. Then we could have skipped the point slope formula and written our answer directly. In any event, there it is. And so now in part B, all we need to do, one more thing, right? We were trying to use the letter P for pressure. So wouldn't it be nice to use P for pressure and to use function notation as well, and to say P of x is 0.0292x plus 1. Okay. And so then in part B, find the pressure at a depth of 10 fathoms, which is 60 feet. Make sure we're using the right units. Our depth, x, was measured in feet in the problem, and so we need it in feet now. So we'll write P of 60, right? The pressure at 60 feet would be 0.0292 times 60 plus 1. And so P of 60 is going to come out to be 2.752. And be sure to use the units atmospheres. And we're all set. Okay, we've just covered a lot of material. That's all for section 2.4 and 2.5.